Okay, this is our first example of a static friction problem. So in this problem it asks us, what is the force that can be applied to a 20 kilogram rubber object on concrete without moving the object? Okay, first off, before you ever start one of these force problems, what I want you to do is make a free body diagram. And so just sketch out what's going on. So I have a surface, and that surface is made of concrete. Okay, and sitting on top of that surface, I have a 20 kilogram object. Okay, now that we've drawn the object, we need to draw all the forces acting on the object. So we have the force of gravity acting on the object. We have the reaction force pointing straight up against the force of gravity. We have some applied force that we don't know what it is, and we have some reaction or some force of friction, that we also don't know what that is. So in this case, we know that this force of friction has to do with static friction because we know that the object is not moving. Alright, and so we know, because we're dealing with static friction, we know that the force of friction is going to be less than or equal to our coefficient of static friction times our reaction force. Okay? And in this case, we know that it's the most force you can apply, meaning if I apply any more force, the object will start moving and I'll have kinetic friction and no longer have static friction. And so what does this mean? So let's look at this. So we know that, and according to this free body diagram, the object's not moving, and if you know it's not moving, you know that there's no acceleration. Okay? Which means that every force has to cancel out. So the force of gravity has to be equal to our reaction force, and our force applied has to be equal to our force of friction. Okay? And we know that according to this, our force of friction is less than or equal to the coefficient of static friction times the reaction force. But in this case, it's the most you can have, the most force that you could have, so it's going to be equal to the reaction force times the coefficient of friction. So I can do some substitution. So my force applied is going to be equal to my force of friction, which I've said is equal to my coefficient of static friction times the reaction force. And I've set up here that the force of gravity is equal to my reaction force, and I know that the force of gravity is also equal to the object's weight, which is mass times gravity. So I can do a little more substitution. Okay. And I end up with mu s times the mass of my object times the acceleration of gravity. Alright, so where do I get mu s? Well, I look up on a table and I try to find, I look on the internet, I look in a textbook, I look in all kinds of places, and I try to find what the coefficient of static friction is for rubber and concrete when they are touching. Okay. And it tells me that the coefficient for rubber and concrete is 0.1 or 1.0. So I say 1. My mass is 20 kilograms. And my acceleration of gravity is 9.8 meters per second squared. And I solve this and I get 196 newtons. Okay, so I can apply 196 newtons, up to 196 newtons of force to this object, after which point the object will begin to move. That's it.